Welcome to class 8, chapter matrix, operation of matrices. Today we will read over the operation of matrices. Chapter is matrix, operation of matrices. Let's start. Here we will read about the addition of matrices, subtraction of matrices. When can two matrices be added, or when can two matrices be subtracted? Addition of matrices. Here we are going to learn addition of matrices and subtraction of matrices. Let's go for addition and subtraction. When can two matrices be added? Let's take an example. If I take matrix A of order 1, 2, 3, 4, its order is 2 by 2, and if I take a matrix B of order 1, 2, 3, 4, 5, 6, 2 by 3, 2 rows, 3 columns. Can we add these two matrices A and B? First of all, before whether these two matrices will be added or subtracted, whether it is possible to add or subtract, we have to check. Let's see first of all the orders of these two matrices. One is of order 2 by 2, another is of order 3 by 3. They have different order. They have different order. One order is 2 by 2, another order is 3 by 3. So A plus B, addition of two matrices is not possible. Similarly, the subtraction of two matrices is also not possible because they have different order. So when can two or more than two matrices be added? When they have the same order. Let's take an example. A is equals to 1, 2, 3, 4, comma, if I take a matrix B is equals to 4, 5, 6, 7. Can we add this? Yes. This is of order 2 by 2 and this is of order 2. Same order. So, addition is possible. Addition or subtraction. You can say subtraction also is possible. Let's add. A plus B will be equals to how much? 1, 2, 3, 4. Its order is 2 by 2 plus 4, 5, 6, 7. Its order also 2 by 2. Let's add and see. First row of first column of matrix A will be added to first column of matrix B. So 1 will be added to 4. So 1 plus 4. First row second column of matrix A will be added to first row second column of matrix B. Plus 5. Second row first column of matrix A will be added to second row first column of matrix B. Plus 6. Second row second column of matrix A will be added to second row second column of matrix B. 4 plus 7. So finally what is the answer? It is 5, 7, 8 and 11. The answer is 2 by 2. This is our answer. We have added two matrices. So in this way we can add. They can give you three matrices. Matrix A, they can give you matrix B, they can give you matrix C. You can add A plus B plus 3 times C. In this way you can do addition. But the matrix A, B, C must have same order. Now similarly for subtraction case, two matrices can be, two or more than two matrices can be subtracted. They are compatible for subtraction when they have same order. Let's say if I take matrix P, matrix example 7, 8, 1, 2, and if I take matrix Q as 1, 2, 3, minus 5, Okay. Let us subtract matrix P from Q from P. Here P minus Q. The order is 2 by 2. This order is 2 by 2. Can they be subtracted? Yes. Subtraction is possible. Why subtraction is possible? Because they have same order. They have same order. This P is having order 2 by 2 and Q is also having order 2 by 2. So they are having same order. So subtraction is possible. Let's subtract. So how much? So first row of first column. First row first column of matrix P. Second first row first column matrix Q. So 7 minus, it is minus sign. So you can, if you do not know, then one step, one line you can elaborate for this, and this is of 2 by 2 minus, this is 1, 2, 3 minus 5. Okay. Now go for, so 7 minus 1, 7 minus 1, first row first column of matrix A, matrix P, and first row first column of matrix Q. Now 8 minus 7 minus 1, 8 minus 2, 8 minus 2, 1 minus 3, and 2 minus 5, 2 minus 5, here is minus sign, so I kept in bracket. So it's 2 by 2, so finally you get the answer, that is 6 minus 2 is 6, and it's minus minus plus, so it's 7. So, right. This is your answer. Here I have added the subtraction of matrices. So finally, what conclusion we have? When can we add 2 or more than 2 matrices, or when can we subtract 2 or more than 2 matrices? This is possible when they have the same order. So before doing the operation of matrices, that is addition and subtraction, you have to take care about the order of the matrices. If their order are same, then this exists, is possible. Let's go more further. Okay, one more example I will take from your book only. Next. Let me take matrix A as 5, 6, 7, 8, comma, matrix B as, these are order 2 by 2, matrix B as minus 1, 3, 4, 5, comma, matrix C as 10, 12, minus 11 and 13. It's also 2 by 2. Now let's do its matrix operation. Here I am doing addition and subtraction at a time, and I am showing you this example. So here solution, here I am writing A plus B plus C. I am doing it roughly. So here how to do? Is addition and subtraction possible? Yes, because first of all, let's check they have the same order. So we can do this. So let's not see here plus, yes, let's say minus. So what is matrix A? 5, 6, 7, 8 plus B minus 1, 3, 4 and 5. This is our 2 by 2. This is also our 2 by 2 minus 10, 12, 11 and 13. This is also our 2 by 2. Let's do first of all addition. So 5 minus 1, 5 minus 1, 6 plus 3, 7 minus 1, 7 plus 4, 8 plus 5, minus. First, let us complete the addition, then we do subtraction. So what is the answer? 5 minus 1 is 4, 7 plus 4 is 11, is 9, and here is 13. It's 2 by 2 minus. Go for this. It's 10, 12, minus 11 and 13. It's also 2 by 2. So now you subtract. So 4 minus 10 9 minus 12, 11 minus 11, and 13 minus 13, 2 by 2. So 4 minus is minus 7, this is what, 11, minus plus 11, and this is minus 3, and this is 0, is equals to, we have minus 7 minus 3 is 22, and 0, the order is 2 by 2. In this way you can solve the problem. So let's take the same example and do the next question. Suppose they may give you like this. They may give you this is the solution of this question. So they may give you here, instead of giving this, they may give you here 3a plus 2b minus c. So let's multiply by 3. 3a here, 2b minus c. So we multiply. Okay, let's leave it. Let's leave this because we have not learned the multiplication of matrices by a scalar. Okay, after studying that, we'll come back. Okay, now over next. Okay, let's take an example. This is commutative property. So here if I say matrix A, if I take 1, 2, 3, 4, it's 3. Its order is 2 by 2, and B, it is commutative property. Okay, no problem here. If B, if I see this, let's take 5, 6, 7 minus 8. Here we need to check, is A plus B is equals to B plus A? We need to check this. So let's check and see. A plus B is how much? 1, 2, 3, 4. Its order is 2 by 2 plus 5, 6, 7 minus 8. Its order also 2 by 2. So let's add these. 1 plus 5, 2 plus 6, 3 plus 7, 4 minus 8, 2 by 2, that is 6, 8, 10 and minus 4, 2 by 2. Let's do B plus A. How much we get? What is B? 5, 6, 7, 8. 2 by 2 plus, what is A? 1, 2, 3, 4, 2 by 2. Will be equals to how much? 5 plus 1, 6 plus 2, 6 plus 2, 7 plus 3, 7 plus 3 minus 8 plus 4. So what is the answer? 6, 8, 10 and minus 4. The order is 2 by 2. The result is same. This and this, the result is same. It is the same. That means A plus B is equals to B plus A. This property of matrix commutative property is true. Let's take an example. If 5 plus is same like this question, is 5 plus 3 is equals to 3 plus 5. Obviously it is 8 is equals to 8. Similarly here also, A plus B is equals to B plus A. Yes, we have proved that A plus B is equals to B plus A. We are getting the same result here. So this is true. So let's pause the video and write this solution and do the problem from your side also. I'm going for next. Okay, let's go for next. Now I'm going for next topic, that is multiplication of a matrix by a scalar. You are going to multiply any matrix by 5 or 6 or -2 or half or -7 by 3. This is scalar. These all are scalar values. So you are going to multiplication of a matrix by a scalar. If you multiply any matrix by a scalar, its all elements will be multiplied by the same scalar. So let's take an example, and I would like to show you something. So if I take matrix A equals to 5, 6, 2, 3. Okay. Here I am multiplying this matrix by 2. Let us take scalar. Scalar here is equals to K and the value is 2, suppose. So what is the value of Ka? So Ka is equals to 2 times matrix A, or you can say 12 by 2, 5, 6, 2 and 3, 2 by 2. Let us multiply. You are multiplying a matrix by scalar. Here I am taking scalar 2. Let's see the result. So when you multiply any matrix by scalar, all the elements or all the objects of this matrix will be multiplied by 2. So let's multiply. 2 5s are 10, and 2 6s are 12, 2 2s are 4, and 2 3s are 6. 2 by 2. This is your answer. Let's check. Suppose K is 2 here, so that means Ka means 2A. Let's do it by another way. 2A means what? A plus A. 2A means A plus A. This I am doing just for verification. So what is A? A is 5, 6, 2, 3. And what is again A? It's 5, 6, 2, 3. Let's add and let us see what will happen. 5 plus 5, 6 plus 6. 2 plus 2 and 3 plus 3 is equals to, finally we have 10, 12, and this is 4 and this is 6, 2 by 2. Same result we have here, same result. So from this we have proved that if you multiply any matrix by a scalar, its all elements or its all components or whatever is your all objects will be multiplied by the same scalar. Again I repeat, if you multiply any matrix by any scalar, then you get a new matrix, which will have the elements of the previous matrix multiplied by that scalar. All the elements will be multiplied by the scalar. You will get the elements of the matrix, new matrix. The elements of the new matrix will be equal to the elements of the previous matrix multiplied by the scalar. So after multiplying by the scalar, whatever result we get, this is a new matrix. A is another matrix and K is another matrix. These are two separate matrices. So result is multiplying a matrix by a scalar. So if you multiply any matrix by a scalar, its all elements of that matrix will be multiplied by the same scalar, and you have a new matrix. I will take one example. So let's take the example. If I take matrix P, and this is 2, this is 8, this is 12 minus 12, this is 0, this is 15, okay, this is 20. 2 rows into 3 columns. Now, can you find 2p, matrix 2p? Yes. Can you find half of p? Correct. 1/3 of p or minus 1/3 of p. These matrices you need to find. It's very easy. 2p, you multiply all these elements of matrix p by 2, you get the answer. I'm writing a result directly. Like example, 2p will be how much? So multiply by 2, you get the answer. That is 2 times 2, 8 minus 12, 0, 15 and it's 20. So the answer will be 2 to the 4. It is 16. It is 24. 0, 30, it's 40. So this is your answer. In the same way, don't do directly, you show stepwise. Multiply this one all and then you show. How to show? Here. Suppose 2p. You need to find 2p. Matrix 2p. Then 2 times this matrix you write 2, 8, 12. Since you are in class 8, so you do it stepwise. Don't write directly. So it equals to what? 2 into 2, 8 into 2, 2 into 8, 2 into minus 12, 2 into 0, 2 into 15 and 2 into 20. Okay, 2 rows by 3 columns. So what is your answer? 4, 0, 16, 30, minus 24, 40, 2 rows, 3 columns. This is your answer. This is your answer. In the same way, you find result for them also. So if you multiply, let's multiply by this. Half of p. So the value of half of p. So half of p is half times half p is equals to matrix p. What is p? Is 2, 8 and 12, 0, 15, 20. So multiply the each element by this. So half times 2, half times 8 and this half times minus 12. Here we have half times 0, half times 15 and this half times 20. 2 rows, 3 columns. This is the final answer. So this is 1. This is 4. This is minus 6. This becomes 0. This is 15 by 2. This is 10. So this is your answer. In the same way, you find 1 by 3p. Multiply by this minus 1 by 3p to all this. So minus 1 by 3p. So it is 2, 8, minus 12 and 0, 15 and 20. 2 rows, 3 columns. Multiply these all elements by minus 1 by 3. So you go for, so minus 1 by 3 times 2, minus 1 by 3 times 8, minus 1 by 3 times minus 12, minus 1 by 3 times 0, minus 1 by 3 times 15 and minus 1 by 3 times 20. What is the result? It's minus 2 by 3, minus 8 by 3, minus plus 4, 0, minus 5 and minus 20 by 3. 2 rows, 3 columns. This is your answer. This is your answer. There may be mistake in calculation also. You check yourself. So in this way, these are some examples relating to multiplication of matrix by a scalar. Multiplication of matrix by a scalar. What happens? You multiply any matrix by a scalar. What will be the result? So these are the results. So here I have shown some examples of multiplication of matrix by a scalar. I go for next topic here. Okay, now next topic is transpose of a matrix. Transpose of a matrix. What do you mean by transpose of a matrix? Suppose let me take an example. If I take matrix P, matrices are denoted by capital letters. As in sets are denoted by capital letters, here also matrices are also denoted by capital letters. Matrix P. P is equals to, suppose 1, 2, 3, 4. 2 by 2. What is transpose. P transpose is denoted by PT, P transpose. You can write simply P and dash at the top. P transpose. P transpose means the matrix formed after interchanging the rows and columns. Rows become columns and column becomes rows. So that is P transpose. So this is first row, this is second row. Now first row R1 and R2. First row becomes first column. So 1, 2, I will write 1, 2 as column. Second row 3, 4. 3, 4 was second row, I made the second column. This is first column, this is second column. Its order is 2 by 2. Order here does not change. Why it does not change the order? Because it is a square matrix. It is a square matrix, that's why. So this is transpose of matrix P. If P is a matrix, then P transpose value is 1, 3, 2, 4. 1, 2, 3, 4. Matrix P is 1, 2, 3, 4. Then matrix P transpose is 1, 3, 2, 4. So matrix obtained after interchanging the rows and columns. Next example I am taking here. Let's take 2, 3, 4, 5, 6, minus 1. It's 2 rows, 3 columns. I am writing here Q transpose. What is the value of Q transpose? How many rows? 1 row, 2 rows. Row 1, row 2. So rows will change into columns. So 2, 3, 4 and 5, 6, minus 1. Now see. This is first column and this is second column. So how many rows here? 1 row, 2 row, 3 rows. 3 rows by 2 columns. What was the order previously? 2 by 3. So if a matrix has 2 by 3 order, if a matrix is of order 2 by 3, then its transpose will have an order of 3 by 2. 3 by 2. If a matrix is of order 5 by 7, its transpose will have an order 7 by 5. 7 by 5. Correct. So you see here. So this is the transpose of the matrix Q. Q transpose, Q transpose, Q transpose, Q transpose, transpose, Q transpose. Now let me go for one example more. Here. How to find the transpose? You might have understood how to find the transpose. So here again I am taking an example. Let us take an example. Here matrix A. So suppose A, B, C, D, E, F. Okay, I am taking in alphabet small letter here. So it is 2 by 3. What is A transpose? What is A transpose? First row becomes first column. That is A, B, C, D, E, F. It has 2 rows and 3 columns. Now it will have 3 rows and 2 columns. First row becomes first column or second row becomes second column. You can change columns to row also. Like first column, let's say first column becomes first row. First column becomes first row. Second column becomes second row. Or third column becomes third row. Either you change into rows into column or columns into row. So A transpose, this is the value of A transpose. A transpose is A is having order 2 by 3, so A transpose is having order 3 by 2. Now let's see one more result, that what will happen. So now my question is, the transpose of a matrix is the matrix itself. You need to prove this. Prove this statement. That is a transpose of a matrix is the matrix itself. It's very simple example. Here I give this marker. See, it is in upstanding position. Transpose ulti, opening ulti, is ulti. Again, this marker you see is upstanding position. इसको ulti, opposite, ulti, इसको ulti, is ulti, ulti को ulti is ulti. So you have the same way. Transpose of any matrix is the matrix itself. So we have already found the transpose. Let's find this transpose of this again. A transpose or transpose. What will be happen? So what is the value? A, B, C, D, E, F. 3 rows by 2 columns. It's transpose because this is value of A transpose. So what will be the answer? First row becomes first column A, D. Second row becomes second column B, E. And this 3F. So So 3 by 2. 3 by 2. So this is same as the question A. This is same as matrix A. So finally we have got the result, that is transpose of any matrix is the matrix itself. Transpose of any matrix is the matrix itself. So we have learned today the operation of matrices, addition of matrices, subtraction of matrices, multiplication of matrices by scalar, and transpose of a matrices. Tomorrow we will read about determinant of matrices, singular, non-singular, and we will do the problem exercise, and this matrix chapter also will be completed. So if you have purchased book, better you purchase book, buy books from market and do problems. If you have any problem, any difficulty while doing the problems from your exercise, then you can ask me. So this was today.